Hi, this is our stats final research project presentation. My name is Dev Shah and my partner is Nikki Roy Chowdhury. And our research question was, to what extent does a person's ability to solve math problems deteriorate with age? So why we chose this question was because we wanted to see if there was a relationship between age and how much information we were able to retain over time. It would also help us to see how much the human brain could actually deteriorate over time. So our data collection method was that my partner and I went to different locations such as school settings, hospitals, gyms, and business offices in the area to ask 10 different people of 5 different age groups the different math questions. The different age groups were children ages 5 to 12, teenagers ages 13 to 20, young adults 21 to 30, adults 31 to 50, and the elderly 51 to 80. Our math problems were 7 times 8, 15 times 5, 3x minus 7 equals 11, x plus 1 times x plus 1 equals 0, and the integral of 4x squared. This allowed for the random factor in data collection, and it allowed our data to be not biased because it was people from a random sample. And overall, we ended up with 250 data points.
This graph shows a left skewed distribution between the variables. This distribution shows that the data shifted to the right side, which means that as the ages of the people who we ask the questions increases, their ability to answer the questions decreases, or the number of seconds that it takes for each person to answer increases too. This graph shows the same thing, that as your age group increases, the number of seconds it takes for you to answer the questions also increases. But it shows it in a better. It shows the trends that occur when you put it into a line graph. Our data analysis shows the R value, which shows the correlation between the data points as you put them in a line based on the questions that they are. And as the R value approaches 1, it shows a stronger correlation. And so when you test the R value to see if it's significant, you get that they are significant, so that you can rely on these R values to show that they're strongly correlated. And what was interesting about our data was that the R values some of them showed a negative correlation while others showed positive correlation. What we wanted is positive correlation based on our hypothesis that we made, but the questions that showed negative correlation were ones that we didn't expect, because it meant that the older people would be able to answer the questions faster, and positive correlation would show that older people answer the questions actually slower.
So in conclusion, because the older generation could answer the simple questions quicker, but it took them longer on the more complex questions. We believe that this could be caused by an education difference because the classes today and curriculum today have changed a lot. For example, someone taking calculus right now would be able to answer the integral question very quickly, whereas a 10-year-old who has not taken any algebra classes yet or any calculus classes wouldn't be able to answer the algebraic problems or the calculus problems very easily. So overall, our hypothesis was supported and refuted by our results.
Thank you for listening, Mr. Lloyd.